So if you have any further problem of the midterm exam, I'm not available this afternoon, so you can combine the before or after next class. Okay, which means Tuesday. I already regrade based on your appeal. Some of them are accepted, the others are not. So you can check your Canvas message. If your score is changed, I posted comment. So I think the GA covered half of the chapter 11. Also, this part is important for your second project. Okay, so I quickly review that part also. Basically, the data in the operating system managed by the file. Okay, so what is a file? A file is a data structure. It's actually the plain file is a sequence of words. In other words, it's a byte. Then it has a format. Sometimes it's a simple format like the simple record structure, or on the other hand, sometimes it has a complex data structure like the MS Word or any other the formatting document tool. Okay, so and in terms of data, it has the file can keep the different types of data, numeric, alphanumeric data, or sometimes it can keep the binary data. Also, nowadays we have the multimedia data, including the image and videos. Each of them should have their own format, their own data structure. So, but we can classify such a file by the well-known types like the text file, source file, audio file, and executable file. And each file has their own attribute, so which means it has their own data structure. First, it has a name, but name is for the user. However, it's a logical name. So, but in operating system, file can be managed by the file identifier, file descriptor. That is a reason that if you see the low-level processing, like the operating, the system code is file descriptor is called as FD. Okay. Basically, the whole device and available source in operating system can be recognized by a file. Okay, not only just a text file or binary file, but also the device, like the attached hard disk drive or the mounting point. Anything can be described as the file. Okay? And each file has a different type, different format, so you can the file has the attribute to represent such a file type. Also, location of the file, where the file is stored and pointed. Okay? And also, file has the information about its own size. So first time when we developed the antivirus program, so we use such a size attribute of the file. Okay, so if somebody modify such a file, including any virus program, modify the inside the code of the file, then they may change the real size, but in that case, the size of the attribute for the size is not changing. So if that is not matched, then it will be suspicious for the infected file. Still use such a basic approach to detect the virus, the antivirus program. And also it has the protection for the security reasons. So we will see quickly about how to protect a file at the end of this chapter. So it has the time, date, and user identification. So this is the example of the file information in the Mac OS. There are operations. So when we define the object in terms of the object-oriented concept, the time after we define the object, we also define the method. It's just similar as the method in object. So in the file, we can define the operation. That operation include the creating the file and writing a data and read the data and search the data. It can be sequential search or it can be a random access search. Also, we can delete the data and truncate data. Truncate means we keep the data structure but delete all the data. Okay, make it empty. Also, when we open the file means we try to, in the program would like to use the source resource of the file. So at the time you can open the file, then you can access. At the time there are two options to open the file: read only or the read and write. So that is the reason when you are doing the C programming, when you access the file, so you need to open the file with R, the read only, or the read and write the mode. Then at that time you can modify the file. Depending on the access mode, the read or the read and write, you can count how many applications open that file because of the blocking problem. So in case of the read, so you can count a number of, you can open the file can be opened by a number of the user, the other application, process, but for the read and write, you can allow only one. Okay, so in your file, you need to mention how many the process are accessing such a file, or how many process are read and write such a file. So it can be managed also in terms from the process point of view. They try to manage how many files are open for a specific file. That is managed in the process data structure in the PCB. So there are two types of the lock. For the read-only, so it is a shared lock, so many process can access such a file. On the other hand, the exclusive lock, only the one process can use the write the file that is an exclusive lock. So these are the example. So you can see the different extension. Extension does not always guarantee the real type of the file. So for example, if you create the Microsoft Word file, the extension will be docx, but you can manually change the extension file. That doesn't mean the file type is changed. Okay, so file extension is just information for the user. Okay. So if you are using the Unix or Linux-based system, including the macOS, so some of the file does not have such a file extension. Okay. So, for example, in the Linux system, you can actually use the command of the file. You can type the file, then file name, then it will show the types of the file. So, for example, if you check the type of the mail is the directory. Okay, and this one is the ASCII text file and command the text file and something like that. So you can use the file command to check the type of the file. So how is the file organized? So we already seen this one. Okay. How we can access such a file? So there are two types of accessing the file. One is the sequential accessing, which means it's from the beginning and keep reading the next byte. And on the other hand, the random accessing is we have the pointer. So we have an index of the location of the information in the file. Then you can directly access that point and read the data from there. So that is the random accessing. So this is a sequential access. So read the next and write the next. Okay. And but direct access, random access require the location of the information and the position to end, then read the next. IBM has the ISOM files index sequential access method. It's still used in the IBM mainframe. Okay, then, so we have a file to keep the information or data in our operating system. When we have the reasonable number of files, it's not a big problem to manage such a file. So how many files do you have in your operating system? Even you cannot count. Why don't you check the number of files using the antivirus program? So if you check your system fully, your antivirus program will show how many files has been checked, right? So is it just 1,000, 10,000? No, it's almost 100,000 and almost a million. It takes a long time to check all the files. So it's not a good idea to keep all such a file, 10,000, 100,000, almost millions of files in one pool of the location, right? Even it's hard to find, hard to read. So even though you know the name of the file, when you open the file, your operating system find where is the file, okay? Then it takes time to address that problem. So we are going to propose another data structure that is called directory structure. What is a directory structure? Is directory physically existing? Actually, directory structure is a logical structure, okay? By grouping the file, right? So similar idea is in the Windows, the operating system, that is the folder, okay? You can create a folder. So for example, when you are using the icon, so probably you have a lot of time, the icon, then app, then sometimes you realize I try to group some of the apps by the folder, okay? At the time you can create the folder, then put all together. It's exactly the same idea. So directory can manage such a number of files. So what information do you need to manage such a file in the directory structure? Directory doesn't have to keep all the information about the file, including data. No, it needs only the just header information. Let me take the information about the file, then keep in the directory structure. Because of that, so when you delete the file, okay? So first, when you create the file, it creates the information only in the directory until you insert the data. So in terms of size, so if you do just a touch of the file in Linux system, touch the command to create the file. Okay, at the time, the size, nothing. It's a 0 byte. But you create the file structure on your directory structure. Okay? So in other words, when you delete the file, it deletes first only directories from the directory structure, not your file. Because of that, even though you delete a lot of file, no operating system actually deletes the entire data. Okay? Which means you can recover such a data. So nowadays it's not a big deal to recover. Even though you format it, you can recover the data until you do the factory format. The formatting means is make the certain the kind of the data structure by following your file system. That doesn't mean it can clear or swipe everything. No. So because it takes a time to remove and swipe and make the all empty. So instead, just delete or just make the header structure. That is the directory. Okay. First, where such a directory and file structure is located is from the disk structure. Disk. Let's take a look at this one. Okay. So your file system actually located in the here each partition is a logical the unit, the data structure. Okay, so several one or more partition can be created under your the physical hard disk. Disk is the physical, the resource of the operating system to keep the data. Then there can be partition first. Then each partition has the header information, then the file. So this is the overview of the file system. Okay. So when you purchase a hard disk drive, the physical hard disk drive is called raw device. So raw device. Some of the operating system would like to use the raw device in case you need better performance. Okay. Otherwise, but it's not easy because you need to use the raw, the address format to access to find the location. Instead, you try to install the file system like the UFS, NTFS, ext268, and what else, the FAT16 and 32. You can use one of the such a file system on top of the raw device, then you can access that one. Such a file system will be located on the partition. Partition is the logical unit to make the certain boundary of the hard disk drive. So like the C drive, D drive, E drive in Windows is the kind of the partition. Even though you have the one hard disk drive, it can be several partitions. So there are different types of the file system. Okay, so mostly when we are saying the file system is a general purpose file system, but nowadays there are specific purpose of the file system, like for example in Solaris has the TMPFS, is a memory based. The file system is a volatile because it's located in the memory. Also it can be used for temporary I/O, which means like when you are sorting the data, you need very fast input and output device. So input and output, the file system. So what if we use the memory as a file system? Even though we lose such information during the operation, it doesn't matter. Because it's not permanent data, it's just temporary data for sorting. We can do it again later. So that is a temporary file system. Also in the kernel memory, we can keep some the kernel, the symbol or the debugging and so on. In your second project, you will implement the portable file system. It's the kind of the specialized. It's not general purpose because it's running on top of your existing the file system. The similar idea is in the Hadoop big data system. So have you ever heard about the Hadoop? The Hadoop is what? It's a data structure for what? That's the question nowadays. Data structure for what? Big data. So what is a big data? It's a big data. It's not small. Okay. So the main problem of dealing with the big data is, so when we are using the single node, the centralized, there might be limitation because of the CPU. Even though you are using the SMP, each processor has a quad core, but anyway limited. It's not easy to make it scalable. Okay, and also it may have the bottleneck, even though you have the very fast hard disk 5 channel, but because you are using one. So why don't we use more node? So this is a distributed system. So there has been a lot of such a distributed file system, distributed operating system, but it's not easy for programming. Also, it's not linearly scaled. It doesn't have the linear scalability. We expect the number of nodes and performance like this one, but mostly like that. Okay, because of the complexity. So to address that one, actually this header coming from the Google. So as you imagine, how big is the Google, the data size? Huge, right? Definitely. But when you search the data, the millions of data will be written within 0.00 seconds, something like that. How can they implement such a thing? So they actually think about how can we handle such a big data. Okay, so they propose a Google file system. This is the another type of the Google file system to handle big data. How can they implement? So you have, for example, Linux and Unix UFS Unix file system for the Linux, and you have the server. So they Google file system actually make the Hadoop HDFS Hadoop distributed file system. If you install such a package, the program, it will install the file system on top of your existing file system for every node. And then there are several service process to manage such a thing. Okay, such a file system. So this is another file system to handle big data. The main difference is what is the operating system clock size. Clock size is a basic I/O unit, mostly 512 bytes, right? Even though you are using the relational database management system, it can be 2K, 4K, not bigger than the 64K. There you can see 128K for each block. Block means it's the input and output. When you read just one record, or the entire block will be written. This one, how big is that? It's the 64 megabytes. Even though you need 1 byte of the data, in this block, 64 megabytes will be read at one time to handle big data. Okay, that is a file system. So this file system is running on the. How can we use this one? There is a command like the header command. So this is your operating system like the Linux file system, and this is a HDFS. So there's a command like the header. So you have the 8.65. If you want to use such a power of the header system, you need to move such a file into the new file system, the header file system, using put command. And get command is a download. Okay, read the data, you need to scan, something like that. Okay, in the second project, you will implement such a small version of file system. So that is which is called the portable file system. So it doesn't have to be only the Windows 7, either Windows 7 or 8, but we prefer 7. The computer lab has a Windows 7 operating system, right? So that's the reason I prefer the Windows 7 for convenience of the GA and me. Okay, but it's not strongly restricted. So if you want, you can use the Windows 8. But the base on top of such a base operating system, you are going to implement the portable file system. Portable file system can do such a operation like the command. So which means you need to implement the program that can run this kind of command. Like it can be, for example, just like the header, it can be, for example, PFS. Then these other can be option like the put, open, and so on. So for example, when you learn the PFS with the open option, open command, and file name, you can create the file system. Allocate the new 10K is the initial size of it. So when you create the HDFS file system, it will use a certain the mounting point, like the, for example, initially 2 megabyte of the area will be reserved for this one. Similarly, in your local the file system, you can allocate the 10 kilobyte the PFS file, okay, file system. That will be, for example, right now I'm in the home and the leaf. So if you run the program here, it will create whatever the name can be. You can decide, it can be varied. So it's a PS file will be created. Okay. This is a file, your file system. Then, if not exists, then you can create. If it exists, you can use such a file system. Then, it's a single user. You don't have to worry about the locking or the how many the files are accessing, or read only, or read. It doesn't matter because it's a portable file system. Okay. Then the next command is a put file. So if you run the put command, so a.txt file, this is the PFS that you create initially 10K, nothing in there. So you can copy this one to the inside the PFS. How can you copy it? You can transmit the byte by byte, right? What is next? Get other. Okay. So if you use upload the ATXT and there is no file ATXT, you can copy. So you can, by streaming the information, you can create the a.txt file. Put get. Remove, you can delete the file. And dir is the list of the file. So you can have the one directory structure. Doesn't have to, we will see the more the complicated directory structure, but in your PFS, you can create only one directory structure for your file system. Then you can list the file. Then, if you wanna add a command, the Linux put R. So put R, where you can store such a put R, the command, in your directory structure. Okay, and the here means you no longer use this one, you can remove this file and quit the command of the PFS. It's just simple, right? You can use any the program language, but as long as it's running on the Windows, somebody already asked what if the Linux system GAME cannot have all operating system, okay? So I strongly suggest to use the Windows base. Okay? So it can be .NET environment, it doesn't matter as long as it can be compiled and run, it's okay. What about the Java? Java can be used also. Okay? But it should be, definitely it's not web interface, it's a standalone program. Okay? And it's much better if you can make the installable the program. Then what if your file total amount of the files in your the PFS is still more than the 10K, then you can allocate 10K, 10K, 10K. So 10K will be kind of the block size. Okay. But I'd like to limit the size of the block by the 20 byte. I don't know. You can allocate. And the file name, there are minor the assumptions, so you can check it. So you can use the PFS1, PFS2, like that. And you add more for you. Okay, one more thing is what about this one? PFS. So you create the 10K, you should have the directory. The size of the directory structure you can determine it. and the other can be used for, let's say this is 1K, 9K will be used for the data. And you are going to use the block-based the I/O, so which means that you are going to format this part by 256. So 256 is the processing unit, input and input and output. Okay. That will be first time is doesn't look like easy, but the block-based approach is much easier to handle the writing the file and delete the file. Which means in your directory structure, you need to manage such a block. How many blocks are available, where your block is located. Okay, so because it's a 10K, you need to have managed the offset. Because it's a file anyway, PFS1 in your original file system. Okay, then when you create this file, the 10K, so it will be named as PFS1, and you have such a data structure of this PFS that include 1K of the directory, the other 10K. So in your directory structure, you need to manage the where is the first block offset. Then you can directly move to there. Otherwise, you need to read all the bytes whenever you access the data. Okay? So if you create the file a.txt, so you have that means you need to manage free block, free list. The free list includes the block ID and offset. These of them. So block ID 0 is the offset 0 is available here. Then you can write the file in this way. Okay. Any question? Start. Okay. So without starting, so first thing is you need to design, okay, your data structure for your PFS. Then your file and your directory structure. What information you are going to manage here? And I need the free list. Okay, what is a free block? Okay, what is the used? Or so because it's not that big, you can manage how many blocks in this one. So let's say it's 1 to the maximum 1,000. You can limit. Okay, reasonable size. Yeah, for each block you can keep the information. This is used. You can have the flag. Just one bit, the flag, whether this one is used or not, something like that. Okay? Yeah, you don't have to stick on the existing approach for the file and directory structure, so you can design by yourself.
Is that more closer to like file open, file read?
You need to use such a command in your programming to, for example, anyway, you need to create such a file, PFS. Okay? But after you complete your program, then the user can use this command to manipulate this one. But to implement this one, definitely you need to use the system call, system library, or API given by your programming environment. Okay? For example, if you are using the Java programming, so you can use the class, you can define the file as a class, okay? Then, as long as physically store such a data, it stores a totally fine. Any question? Yes.
We need more information.
Need more information about? You can ask me right now. What information do you need?
Both the file system work on the same machine. This is not it work.
As we have discussed, operating system does not have only one file system. So many file systems exist in one operating system. Even certain file system running on top of existing file system. Okay, you are implementing this one, simple file system on top of your file. For example, you are using NTFS. So on top of NTFS, your PFS is running as a file. from the NTFS point of view, this is nothing but one file. Okay? It can be binary file, I think. Any other question? That's, I know, I understand. If you do not understand what file system is, this is the most difficult part to understand. What do I need to do? Right?
That's my point.
You are going to implement one program. So, for example, let's say this is a PFS, the program. This PFS program has the several options, like this one. If you type the open option, it will create the PFS dot one file that is 10K size. Okay? What kind of file this is?
And what is based on NTFS? Based on NTFS?
Any file system is
Any
fine.
file system.
Yes. On top of that. But from the this, your file system point of view is nothing but file. Like the MS Word, like the other. But this one has their own format, data structure that follow file system structure. Once you learn this command, this is one file system. If you log out, if you close this program, then you are running on this original file system. It's nothing but file. Okay?
Do I need format, like something like format this area?
If you want, you can make the additional command, additional option like the formatting or whatever. It's totally up to you how to design. Okay? The key point is you need to design how you are going to organize this file. Okay? What about the MS Word? MS Word has their own format, their own data structure. It has bunch of the menu. It's actually nothing different from what you have done in your programming class. In your programming class, have you ever created a file? Yes, you did. That's the same thing. Okay? Because of the name of this file system, you're confused. It's nothing special. Okay? It's a program. In your program, you create a file, but this file is organized by this rule. Okay? That's the only difference. Yes.
If I have two files, I have to use the two files. I want to transfer it to the portable files. Okay.
Yes. You have the file a.txt file here.
Yeah.
You can copy it into this one by following their own.
Then what about the second file? I have to append it inside.
Not append, it's a separate file. So for example, a.txt file is here. Its size is 10 bytes. Okay? So when you put this file, so there's nothing, so empty, so all blocks are empty. So you can use the first block and copy 10 bytes over here. Then you need to keep certain information about the file in your directory structure. Okay? The name is a.txt file and size is 10 bytes. Of the block number is the 0 and the offset is something. Okay? When you read this data, like using the get or whatever, then first you need to take a look at this header information, then find the location. If you want to upload the b.txt file, okay, it's up to you. You need to decide your policy, whether one block can keep the multiple file or the only one file, mostly multiple file. So you know this block still has the available spot. So because it's so you need to manage another data structure to keep like this one. The 11 byte through the 255 are available. So you can write this is the 20 byte. So 20 byte is the copy to this location. Yes.
If I delete the file in the interface system, that's what.
No, that's not fair.
That's not it. That's mean I
Because
can't.
it's a separate. You copy it, then delete. This is still exists
Yeah,
over here.
okay.
If you delete the, so for example, you have the my information in the operating system. So you copy and paste to the MS Word, my information. Then after you delete the operating system file, then does it affect the MS Word information? No, it's a separate file. It's the same thing. Okay? It's not rocket science. So you are implementing certain program. But I understand most of the students confused because how can I develop the file system? Okay? File system is just a software. It's so 99% same, okay, as what you have done in your programming class. But in this project, you will implement the file system data structure. It's simple. Okay? Think about the other program languages, the other project in other classes. It's the same thing. The professor or GA will give you the certain description. It's a data structure. Okay? In your programming, you are implementing such a data structure. That's it. Any computer-related project is the same thing. Your customer, the project manager will give the order. It's a data structure. Okay? You will implement in your programming. It's the same thing. Okay? Simply everything is the same, but because of the name of this project, file system, the student got confused. So how can I implement the NTFS style, the file system? At that time, definitely you need to know raw device, raw information. Okay? What is the, for example, this file system starts with DV, HD, D1, 0, and the offset. But this one is running on top of existing file system. You can get the benefit of the existing file system. As a file, it can be file system. Okay? Any other question? Okay. So I think some of you are taking the big data course, or took the big data course, or they're taking the NoSQL data. Quite similar. It's as similar as the HDFS. Okay? Idea is exactly the same thing. Okay. So what can you do with a directory? So you are going to implement this kind of thing in the project. Okay? Not all of them. Okay? So using the directory structure, you can search the file. You can list actually, and create a file. When you create a file like the touch, the command actually is from the directory structure. Delete the file, delete the directory. Because of that, even though you delete the file, that doesn't mean it delete the data. It delete only the information in the directory. So in this case, even though we remove the file of the a.txt, it doesn't delete this one. It delete only directory information that make the free. This block, occupied block is free. Then later, when you copy another file, it may be overlap, but sometimes it can be right the other. If it still uses, it can be recovered if you read byte by byte. That's the same way how some of the company restore, recover your hard disk drive that you delete. Also, you can rename a file. When you rename a file, we don't have to copy entire data. Instead, you can just change the name of the file in your directory. So, using the directory, definitely efficient. Too many, the number of files. Also, naming. So we will see the example of such a naming of the file in the directory, how much convenient for the user. Okay. For example, I'd like to create the contact file. What if the other user, okay? If you are using the only one without directory, so one file system, all files are located here. So if somebody create a contact.txt, the other user cannot create the same the file with the same file name. Okay, but if you are using the directory, each user may have their own directory, so they can create the same file name. Also grouping. Grouping means you probably in the iPhone or the Android phone, you try to group the apps by the folder. Game, you put all the games in the same folder. Okay, and the editing tool or some other, you can put the same. So that is the grouping. So this is the single level directory structure for all the user. So we have only one directory, one level of directory. One is a cat, bull, a, something like that. But the all user will share this one. There might be naming problem if the user want to create the file with the same name in the same directory. You cannot create this. So also, but the grouping is good. We can group by such a directory. So we can make the two-level, multi-level directory structure by the user. So that is the reason in Linux, each user has their own directory. Okay, then can create their own directory or files. The same idea. But when you have the multi-level directory structure, to access the file, okay, you need to specify the directory, the path of the directory. So this file from user 1, then cat, then finally file. Otherwise, if you are using only the file name, so there you use the same file. There is a file with the same name, so it can be confused. So you need to use the path. Okay, there are two different types of path. As you know, one is absolute path, and another one is relative path. Absolute path is from the root and slash. The relative is the dot means current directory, current location. Dot and dot is a parent location. So same thing in Windows operating system. So eventually we can have such a tree structure. So this is popular in any operating system. So when you access the data, the file, when you access a file, you can start from the root. Then, for example, this one is spell, the mail, and printer, and first, something like that. All of these are directory structure in the example. You don't have to implement the multi-level structure because it's a personal, the portable, the single user file system. So you can have only one directory structure that can manage your entire file system. There are two types of the path, absolute, everybody knows it. Okay. How can we, by the way, the last class, I think the last week, the Tuesday class, I ended at 11:45. Did you remember? So somebody should let me know. Actually, I got confused with the class. It begins with the 30. That end 45. So I wonder how I should have covered more than that, but I couldn't. I realized when I was in the parking lot.
We thought you would be nice.
Okay. So it's the same thing as your project. You need to implement the remove rm command and make a directory. So you don't have to implement the make a directory because it's a single level. It's the same thing, same idea. So first thing is you need to design your data structure of your file system. Okay, that's important. What information you keep. Okay? That is the first thing you need to do. Then this information is not in your memory. Okay? So if you keep such information in the memory, what happens? If you shut down your file system, you lose all the information. So definitely you need to keep your here. What another way is before you, it's risky, but some of the students would like to from time to time write, because managing such information in the memory is much easier, right? You can just define object or the struct, right? Then manage it. The problem is you can lose some of the information, so it's up to you. As long as you can keep such a data. But if you possible, why don't you keep your such a directory the information about your file system in your part of the file system. And another problem, another thing that I read from the previous project is that many of the students are hesitating to open the file and read the file, write the file, and close the file. I don't know why. Okay? So do not hesitate. Don't be scared to handle the file. Okay? Yes.
I need to open the file. I have to know the offset and the.
You need to design.
Yeah.
Right.
To
So
start.
for example, so such an information